forget to start recording like I did last time. So, how was the exam? Hopefully, it wasn't too bad. All right. So, one thing with regard to the exam, I had it set up so that you could see your responses, but you couldn't see whether or not they were correct. I believe I changed the settings last night so that or this morning, so that you should be able to see whether or not your answers were correct. I'm not sure if that took effect, if it'll let you do that, but hopefully it should tell you whether or not some of the auto-graded questions were correct. Obviously, I'll have to grade you on some stuff, so don't freak out if it says you've got like 40 points out of like whatever or something like that, because there's a bunch of other questions I have to grade by hand, you know? So it will just simply do that. Now, please keep in mind that there are people who will not take in the exam for various reasons. So when discussing answers about the exam, please, discuss with only with people who have already taken the exam. That makes sense, right? Yeah. Okay. So also, if you feel like you chose a correct answer, but it should be worth, but it wasn't, or you're graded unfairly, please let me know. My goal is I'm going to send out an email to the TAs tonight to get them to assist me in grading, so that we can get some grading done sooner rather than later. Because I don't know what Temple considers a good turnaround time on grading exams. At my previous institution, a good turnaround time was considered to be about, oddly, 10 days. That's what they defined a good turnaround time for exams to be. And I do try to keep to about a week to 10 days on the turnaround time, so I will try to get that to you. Just keep in mind, I've got 200 students I've got about 200 students combined between both my classes to grade. So I try to set it up as easy as possible. But again, if you have any issues with your grade, or that you thought it was worth more, please let me know, or if there's ambiguity. Now, one thing I did neglect was on the group exam to put a field to say, who did you work with? I neglected to do that. I'm not sure how y'all resolved that. Yes. You put it in the comment. Oh, great. Okay. Yeah. If you didn't let me know, then let me know either via email for a comment, just some way to let me know who you worked with. That way, everybody who needs to can get credit. Or if you worked with somebody and they got credit and you didn't, just email me. This is not I'm not going to penalize you on this one for forgetting to write your name on the thing where I didn't provide a form for you to write your name on. All right. So, I tried some different questions this time around. I'm trying to do some new questions. In 2168, I did a new question that utilized ChatGPT, which, if you aren't familiar with that yet, that's the big thing in tech news, which is generating text. And I had ChatGPT generate me some prompts. The prompts were wrong, or some of the prompts were wrong. Okay. But I'm like, I know these are wrong. I just instinctively know they're wrong. But students might not. So I simply just took the prompt and said, hey, these are auto-generated prompts, which are good and which are bad, and why are they bad? So that seemed like a very good thing. Again, it's all about figuring out the best way to utilize technology. Now, one thing I do want to mention before I forget it is that I've been diving into retro gaming and stuff, which is why I picked up this thing over here, which is a little Game Boy, totally not legal knockoff of a Game Boy. But what it led me to discover, because I really enjoy homebrew games and those kind of independent student-made games, because with those kind of games, you get a level of expression you don't normally get in a product that is attempting to make money. They're much more often really expressive in what they want to tell. I found that basically there are a number of resources that are built for making retro game ROMs, files that could run on actual hardware. If building an old style game is something that interests you, that is something to keep in mind for a final project. There's things like GB Studio that allow you to do that. There's I know there's some tools for doing Game Boy Advance that probably made it easier. I know for a fact that there are tools to write for Game Boy Advanced because I've done so. That was actually part of my required curriculum for my undergrad for learning operating systems and systems organization programming. It was pretty intense. Because it was all hardware addressable. You could like individually address pixels by memory location using the Game Boy Advance. It was pretty nifty way to do it. But what I'm trying to get at is that there are all sorts of, if there's something that interests you, there's probably a final project you can find around that. And I will have lots of suggestions as we come up closer and closer to that. Again, you don't have to even start thinking about it now, but if it's something you want to start thinking about, you can. Now today, what I've done is I've moved module 4. Sorry, I've moved module to module 6. This Blame Pope Gregory. Now the upcoming assignment, Lab 6, right? It has 4 exercises. There's 2 pairs. You choose one of each of the pair, right? Mario, if you're feeling less comfortable, or Mario, if you're feeling more comfortable. And then cash or credit, depending on how you feel you're progressing in the class. The first one is basically giving the appropriate amount of change, and the second one is checking credit card verification. Basically, is this a valid credit card, and what is it, what type it is? Because there are certain algorithms. These credit cards have built-in verification that you can't just simply plug in a 16-digit or 15-digit or 14-digit number and have it go through. There's a specific layout for it and specific format it needs to fulfill for it to be a valid credit card number. So that allows you to kind of learn about that. And for testing for that one, you get to look at actual like PayPal documentation about their specific credit card numbers. And I'll just go to that for one here. There are specific numbers over here. And they changed this URL every few years or somewhat, where we have these credit card numbers that are specifically designed, and I'm not sure, I think they're designed by the companies themselves for testing purposes. Just simply saying, hey, does the algorithm, here's a valid credit card number a credit card number that you can test that doesn't actually, that our system will recognize as not something that's that is just a test number. So nobody can make transactions. But if you're writing your application to identify credit card numbers, you don't actually have to put in your own information, which seems a little silly, So all sorts of things and what they, different ways to test it. So that's a pretty nifty thing to do. Now, what we're going to do today is my exercise called Blame Pope Gregory the 13th, which is you find that on Canvas. It's not going to be on Runestone. The PDF, again, you find it by going to modules or under assignments, because this is, again, right under here, our in-class exercise, Blame Pope Gregory the 13th. In reality, this is just simply a funny name. I don't think, I mean, obviously, Pope Gregory didn't probably sit down and figure out the Gregorian calendar himself, but it's named after him. So we're going to learn about leap years and the way leap years work and the fact that time is terrible. It's awful. All right. So our goal is to write a program that, given a string as an input, test whether a string is a valid date in the Gregorian calendar. Now, the Gregorian calendar is the current most widely used civil calendar. It is the one that has been adopted as secular calendars throughout a lot of nations. Okay, it was developed, and in my footnotes you'll see that it was developed it was commissioned and instituted under Pope Gregory the 13th. And it is the calendar used by the United States. Now, there are other calendars that are out there, right? So, for instance, we have the Gregorian calendar. And I'm actually going to, it's actually kind of fortuitous that we're doing this the day after President's Day, because it's relevant. Because before we used the Gregorian calendar, civilly, it was the Julian calendar, which is where the rule that you're familiar with comes from, which is that it's a solar calendar, meaning that it's the dates indicate the season apparent based on where the sun is and where we are rotating around the sun. It's still used by the Eastern Orthodox Church, as well as parts of the Oriental Church, as well as the Berbers, it says here. But basically, a leap day is added every 4 years without exception. Basically, if the year's divisible by 4, that's a leap year, and we add a leap day in, an extra day to kind of catch up for the time. This is because the solar is what we have as a year is about this much. It's about 365 days, 5 hours, 48 minutes, and 45 seconds. That's how much about a year is. It's not exactly 365 days because that's two different things. That's a day is the rotation of the Earth, whereas we're talking about for a year, that's the Earth revolving around the sun, which is different things. So it makes sense that they don't fully line up. Now, the fact that this was instituted, the Gregorian calendar was instituted, is why we get some weird stuff around President's Day and George Washington. Let's go ahead and look up George Washington, Wikipedia page, okay? Like, what's so interesting here? Look at the first thing, date of birth. It has an immediate footnote. Why does that have an immediate footnote? Because contemporaneous records written of the time of his birth used the old style Julian calendar, meaning that his birthday would have been recorded as February 11th, as opposed to the dates that have been reset ever since, which has been February 22nd. Okay. So his date of birth is kind of like, if you'll see documents that say what his date of birth is, and that's February 11th, but the calendar changed everything. And it basically moved everything 11 days forward because what happened is that because of that weird thing with the Julian calendar, that leap day, right? That made the average year 365 days. 365 and a quarter days, which was close, but you still got a level of drift. And by the time that we got to around his birthday, it was about 11 days worth of drift, I believe. So now the Gregorian calendar makes it a bit more accurate. It gives us 300. It basically gets the average year's length down to 0.2425 days. Okay. So the Gregorian calendars, and again, the Gregorian calendar is what we use, and that doesn't even get into all sorts of religious calendars. And we have a list over here where it says, hey, 2023 in the various calendars over here. Note that basically that they have different days, they have different spans because not every calendar abides for, it says, okay, this is the new year. This is when we update the digit in the ones place in the years. Not everybody does that on January 1st. So all sorts of things. Fortunately, almost everything gets converted into Gregorian. At least we have one system we can all rely on. But again, as I mentioned in the footnotes, it was a tough thing for a while. A number of countries resisted using it well into the 1900s. All right, so what makes the Gregorian calendar so special? So let's go back to our PDF for a second. So Gregorian calendar says valid months are from January to December. They're 1 through 12. September, April, June, and November each have 30 days. All other months but February have 31st, which has always struck me as weird, but hey, it's consistent between the Gregorian and Julian calendar, so hey. And then February is our leap month. February, or it's the month that has leap day, I should say. It has 28 days, except on a leap year where you have 29 days. And leap years are not as easy as you think because you get taught the Julian calendar rule because it's good for almost every year. Years that are not divisible by 4 are normal. Years divisible by 4 are leap years, except if that year is also divisible by 100. Unless that year is also divisible by 400, in which case it is still leap year. So for example, 1644, that is a leap year because it's divisible by 4. 1645 is not a leap year, it's not divisible by 4. 1600 is a leap year because it's divisible by 4 and 400. 1700 is not a leap year because it was divisible by 100 but not 400. It's that logic kind of gets really annoying. Let's go ahead and go to the Wikipedia and see if they wrote it any better than I did. They probably did because they've had there's a lot more people with eyes looking at it. Every year that is exactly divisible by 4 years is a leap year, except for those that are exactly divisible by 100. But the centurial leap years are leap years if they are exactly divisible by 400. For example, the leap year 1700, 1800, 1900 are leap years, but the year 2000 is. And this is why I say we get taught the divisible by 4 rule, because, I mean, it was that, the question of whether 2000 was a leap year or not never came up because it was a leap year. So we could just get taught the Julian calendar rule, and you're not going to have to worry about it until year 2100. And I mean, hopefully we'll all be alive still then. So that would be great. That'd be great. And that would be great wondering whether or not 2100 is a leap year. I hope that's the most significant problem we have to argue about. But what this comes down to is for this assignment is that I like it because it doesn't require, it's annoyingly difficult and non-trivial for any programmer at any difficulty level, because that logic is kind of twisty. It's non-trivial. So what we need to do here, we need basically a couple tools to begin, which is we need to remember how to slice strings, because we're going to be getting user input from the user, and we need to be able to convert a string into an integer. So we're going to do this together, but the idea here is that leap years, despite being the bulk of the mental work we're going to have to do, they're fairly rare. So we're going to leave that part of it for last. Instead, we're going to focus on, okay, did they give us a good date? Did they give us like December as a bad date, the 13th month or something like that? We can reject that as an invalid date. Same thing with April 31st. That's not a valid day, right? So we can reject April 31st or April 32nd or November 50th. Those are dates we can reject. Only when it's February, and only when it's February, and only when the user says the day is 29, do we have to bother checking if it's a leap year or not, right? So let's, handle this problem like most rational human beings do, which is avoid it for as long as possible. Now, I believe therapists say that is not a healthy strategy, but it's a great strategy for this problem. So what we're going to do is that we are going to open up idle, and we're going to first take in what we need to from the user. So I'm going to call this program, we can call it leap year, you can call it blame Pope, because again, the leap year, because again, the joke here is that it's all his fault, all Pope Gregory's fault that you now have to sit through this in class. That's the joke. So let's see. So the idea here is, so we're going to get the string from the user. We're going to assume that they give us this string, something in month, day, year, year. If they want to give us like November, the 9th, sorry, if they want to give, not November, they want to give us September, they're going to give us 09, right, as the month. This is not an issue for Python or Java or any programming language to handle with that regards to that. So the first thing, let's do that, and let's just simply take an input statement. Input, please enter a date in mm/day/year format. And the reason I specify that is that's the way that it's done in the US, which honestly has always seemed a little bit backwards to me, because it's out of order. Like the month, it's got like the units are not ordered in size, right? And it really feels like it should be ordered in some order, but hey, I'm so used to it at this point, whatever. So let's go ahead and give this a value called date. And what we need to do is extract from date, which is a string, 3 values. We need to extract the month is equal to something, the day, which is equal to something, and we need to extract the year, which is also equal to something. And then and for each of those, we want to convert them into integers, but for right now, we just need to extract them. Now, what we're going to be what the user is going to input is something along this format, which is month / day / yeah, I know I've said this already, but now the reason I'm doing this here is because I want to line up your indexes 1, 2, 3, 4, 5, 6, 7, 8, 9. Convenient that it's all 10 digits there. Give me 1 second. I'm just simply splitting the screen appropriately. So over here on the hints, here's a reminder on how slicing a string works in Python. So we are going to solve this by slicing the string. So I want you to slice the string that will give you these 2 digits over here in month. You don't have to convert them into integers yet. We'll do that after we do so. Slice so that we get the day, and slice so we get the year. Went ahead and labeled the indexes for you. So take a couple minutes to try slicing it on your own if you haven't done so already. Right, and on the right is instructions and reminders about how slicing works, which is that allows you to get small bits of a longer sequence. Actually, let me go ahead and that way I can actually get it readable. And again, if you have issues with this, feel free to raise your hand and I can help you, or bother your fellow victim. I'm sorry, student, not victim. Your fellow student here. Yes. Oh, yeah, what you want to do is grab month, and you don't have to copy with the comments. The comments are there to help you line that up. Let me go ahead and okay, here we go. Easy to read now. You don't have to copy. Zero. The reason we do is that what so we get to God, it's only like 2 minutes. Since each of those things we want to get the months, the digit from that month, the month for each month. So you want to get the first two characters with their names. We'll give it a minute or two more, so they still keep people typing it up. All right, so I will go ahead and give you, let's go ahead and move forward on this. So for the month, what we need to do is, well, we've actually got the answer kind of already here, which allows us to slice, what we need to do is slice off the first two characters of this letter, sorry, of the string. So what we've got is we've got date as our input, and we want to go, and we want to start at index 0 and go up to, but not include index 2, right? So it's 0 to 2. Now the number, and again, part of the reason we do the up to but not include is that we can use subtraction to tell us how long the string is going to be. It's 2 minus 0, so it's 2 characters long. Okay, that gets us the first 2 characters. That gets us this, because it starts at 0, goes up to but not include index 2. For date, that starts at index 3 and goes up to but does not include index 5. So for date, start at 3 up to but doesn't include index 5. 5 minus 3 lets us know that it's 2 characters long, but we already knew that. 6. And so we can, so over here, we've got a couple different ways to do this one, literally a couple. We can start at index 6 and go up to, but not include index 10, which would be the index after that. So we can include index 5. Another way though, and the more preferred way, is that we can omit, is that we can just do 6 colon and omit the end. If you remember, if you omit the beginning or end, omit, not emit, if you omit the beginning or end, you can, Python will try to figure out the most, will do the least surprising thing. So it will go all the way through to the end. Similarly, if we didn't indicate that we wanted to start in index 0 and just did :2, it's going to say, okay, we're going to start at the beginning and go up to and not include index 2. Both of these are perfectly valid solutions for either of those. Okay, I'm going to go ahead and just line that up to make it pretty. And then what I'm going to do is I'm going to go, now we can't do this now just to make it easier on us because we could operate on strings, but doing so with doing comparisons with strings is going to be a bit annoying because we'd have to, you know, do more double quotes, and I don't want to have to do that. So I'd rather just simply just turn them into numbers to make that comparison easier. So int, and this will just turn them into whole numbers. Int date. Now, the next easiest thing that we can work, so we've been able to figure this out. The year doesn't matter unless it's February. So basically, and the date, sorry, the number of days in a month, whether or not that's valid depends on what month it is, right? We don't know how many days are going to be in the month unless we know what day it is. So we should split up. So what we're going to do is we're going to write some if statements, which is that we want to basically figure out our logic based off of different categories. So basically what we want to do is, and I'm going to write this in pseudocode for you to fill in your own. If it's a day, you know, month that has 30 days, else if, you know, it's a month that has 31 days. So it's either going to be a month with 30 days, it's going to be a month that has 31 days. Else if, I didn't just do an else there for one, and you'll see why in a second. Else if month is February, which always, I always have trouble spelling. Because, you say February and there's not a, but that's not how I spelled it. It's February. Feels weird to say. Anyway, else. It's invalid, right? If it's not one of those three categories, they put in a bad month, right? Like if they put in 13, we'd get this case over here. So let's go ahead and split this up into our outline. Now, what I would suggest doing, because otherwise, is that you can put like print statements in each of these as you write them. So if expression colon, right, you do your Boolean expressions, then you do a colon, and then you can do something like print 30-day month. That way you can make your Python interpreter editor isn't going to get confused by your indentation. So let's go ahead and work on the first if statement, okay? Work on doing the first if statement, okay? In other words, check if it's September, April, June, or November. And you're wondering why? Well, it's just an if statement. Why? Well, because I phrased it differently than you'll write it.
Yeah, sure, that's fine.
Yeah, those were basically, did I do the research that I was hired to do? Okay. So let's go ahead and work on this portion. So now there's a reason why I took a break to let you work on this, because there's a common error that happens in Python on here, and in other languages it would just throw up its hands and yell at you, but in Python it says, yeah, cool, and it doesn't care. So let's go ahead and do that. So if month, so first let's go ahead and put this in order. If month is equal to April, so if month is equal to 4, or, and this is where the mistake comes in. So you think, okay, if month, and this is what I typically see, if month is equal to 4 or 6 or 9 or 11, which makes syntactical sense to you or me. It makes total sense for you and me, and Python's just super happy about it, right? It's perfectly happy to let me do this. So I'm just going to simply comment this part out and run it, and we'll see that it says April 04 11 2020. It says 30-day month. That's correct, totally correct. But however, if I say January, actually, let's just give today's date. 02, 21, 2023. It's going to say it's a 30-day month, which is, it's not, month is not, that doesn't seem like we hit anything. For this, we can blame Stephen Colbert instead. You see, Python uses a concept that was named by, that they took the name from Stephen Colbert, which is something called truthiness, which is that it's not exactly true, but it sure feels true. So what the OR statement expects here is that it expects on either side of it to be a Boolean expression. It expects this to be a Boolean expression, something resulting in true, false. That to be a Boolean expression. It expects the 9 to be a Boolean expression, and it expects the 11 to be a Boolean expression. Make sense? It expects all sides of those to be Boolean expressions. So it's not kind of like a list of things. So why is it resulting in true? Because of truthiness. In Python, it allows you to take some shortcuts, which are useful and very annoying if you aren't used to them, which is that most programming languages say the if statement needs to resolve to a Boolean statement, and Python's like, anything can be true or false if you want it to be. So anything that is a non-zero value is true. Anything, and it's truthy, I should say. Anything that is 0 valued is falsy. It feels false. So over here, what we're saying is that if month is equal to 4, okay, it's not equal to 4. Let me check the next clause. Or 6. Well, 6 is well, that's the only thing in the expression. 6 feels truthy. It's a non-zero value, so we're going to evaluate that to true, because that's true. The whole thing is true. It's a weird thing. Very weird. So 4 or 6. So what we want to write is something like this: 4 or 6, or month is equal to 9, or month is equal to, my God, there's got to be an easier way. Yes, there is an easier way. Why would I be showing? This is annoying to do, right? I went off the screen already. I mean, half the screen, but you get the point. Yes.
Could you use like double lines to express 4 instead?
So that's an excellent question. Now, the other programming languages use so other programming languages you will learn, like C and Java, and pretty much every C-based programming language will use that symbol for or and this symbol for and. They'll also use this symbol for or and the symbol for and in case you want to disable short circuiting. Oh, and you'll also use this for binary or, and this for binary and this for binary XOR. And now you know why Python got rid of that, because that is a lot. And for the most part, people just use the first two, right? I don't mean that to say that to be like, but it's seriously, it's a lot. Oh my God. So the difference, because the idea here is that, again, is short circuiting. The idea here is that since 6 was true, I could just simply stop evaluating all the other expressions because the whole expression would be true. But you can disable that, but you only want to disable that if you're doing statements that Python hates you to do, which is inline kind of incrementation stuff that Python disallows because it makes everything super hard to read. It says, make your statements simpler, guys. You can do that. But yes, other programming languages use the binary or like this and the binary and. I like Python's better because it's more readable and there's no kind of confusion about what it's going to do. Yeah, so I think, let's see. I'm not sure if you can do this in Python, or what it does, but it doesn't do, let me just see for a second. Okay, can I do 5, 7? Okay, yeah, it gives me an invalid syntax, but I can do 5, 7 and that and get that. It does still enable, so those are specifically in Python relegated to binary operations, meaning translating these numbers into ones and zeros and then doing binary operations such as or and on them. Which basically says, are the digit, flip the digits accordingly based on what's in the two numbers. Yes.
Figuring out the month, I just said like this month equals like 1, 30, 5, and that also works. Like, is that like a good way?
Yep, I was actually about to go about that. There's or something like that. This is what I was going to show, which is that if month, so we can make this a bit shorter by using lists. If month in 4, 6, 9, 11. Make a list of all the possibilities. And if your month is one of those possibilities, if this month is in there, was that what you were kind of getting at?
Yeah, I just like set it
equal. This equal operator would ask if it's the same thing. Is that what you did?
Yeah.
So that would ask if the month is a list called 4, 6, 11, or sorry, 9 or 11, which would not be what you want. What you want there is the in operator. Yes. Like that. Month equals this. Did that work for you? Be interesting to see. 01. It works for you? 01, comma. Heck. Doesn't work there for me, at least if I do month is equal this. So yes.
I got weird like I got the one at the end, but it said like this, like what the month like practically at the start of the month. And then it works.
Oh, interesting. It does. That's real. So something like this. Huh. Let me see. Let me go ahead. But that's confirmation bias on my part. So let's go ahead. So I need to now I need to attempt to disprove it. Okay. That's not simply saying to say you're wrong. It's the way you do things and, to make sure that we don't operate under false assumptions. The way you handle new discoveries is that you attempt to disprove it. So that works for a 30-day month. Same kind of reason why there. It says, oh, sorry, it doesn't work for that. It says 12, 21, 31, 13. So it activates during December, and we don't want December. And I'm sure this is coming down to what we were talking about before, which has to do with the truthiness and falsiness of statements. See, if you try it on your end, right? Plug in December, it's got to discriminate against being in one category versus being in the other category. Make sense?
Yeah.
And that's the trick with Python. So that's why you want to make a list. Or in the case of parentheses, if you do this, this will also work because it's using something like a list called a tuple. And that will work as well. But for the most part, we just like using lists because lists are changeable. And that's a big part of why we use tuples, because they're not really changeable. That manages to say, okay, it fails on February. Sorry, it doesn't let you in on, it doesn't print out on, not February. It doesn't print out on January, but it will print out on, let's do 09, 21, some other, and prints it out there. I find the format of in to be a lot more useful than or a lot quicker than doing the month, day, year. Python is very cool about letting you do really weird things with it. But you got to be careful about that with Python. Let's go ahead and finish up the rest of these, right? Else if month is, well, basically everything else but December. Else if month in February, March, we skipped February, so January, March, April, May, June, July, August, September, October, November, December. And that's pretty much the rest of them, right? Else if and we will go ahead and put a colon there before we forget. Print 31-day month. Month in month equals 2 because we only have one thing to check. Print Feb, and then else print invalid month. Not invalid moth. I keep typing moth. Okay. And again, this versus double equals. Both of those are perfectly correct ways of doing it. I personally like doing in because that's a very quick way to do it in Python. It's a test for membership. If for those of you who are coming from a math background, the in operator, again, that's the same as doing the tiny little, is part of operator. I is element of big. That for those of you coming from a math background, that's exactly what that in operator is doing. Oops. Here I kept trying to undo. I was undoing the wrong stuff. There we go. So now what we need to do is, now that we've figured out how many days a particular month the specified month has, we need to test whether or not it's valid. So here what we need to do is check, okay, is the day range in here valid? Is it between 1 and 30 inclusive? If it is, print out that it's valid. Otherwise, print out that it's invalid day. All right, so take a couple minutes to work on that, and then I will show you a couple different ways to do that. Because here's another spot where I get a lot of complaints from students once they are done with Python and move into Java that they can't do it anymore. Other languages aren't so nice. Oh, sorry, yes. Yes. If you look at the hazard of teaching two languages at once. The hazard of teaching two languages at once is that sometimes you totally mess up the syntax. Supposed to be elif, not elsif. Silly Python. Sorry about that. That's totally my bad. But it should be elif because again, Python wanted to be different there. And that's a difference that I think is harmful. Because every other language does else if. Again, teaching two languages at once, sometimes I mess it up. All right. And again, keep this moment in mind when you mess up. Notice I've got, over a decade of programming experience here. This is a fairly basic error. I made it and couldn't figure it out. And somebody pointed out, I'm like, oh, right, of course. This happens. Right into the field that you can put it in the format. Yes, well, yeah, some it is that they're gonna put it in a month, a day, and a year, otherwise it's programmed in. Really annoying. All right. All right, so now that we've got that hiccup out of the way, let's take a look at this. All right, so first off, we need something here that has less, so we want to make sure that it, you know, if it's in the correct range, it's valid. If it's in the incorrect range, it's invalid. So there's two different ways we could do this. We could check if it's invalid or we could check if it's valid. In this case, doing either approach is easier, although we'll find that in Python, checking valid will be easier when we figure out Python's regular syntax. So for instance, if I want to check if it's valid, I could say, hey, if I want to check if it was invalid, I could say something like if day is less than 1, or for some reason, maybe they hit negative, I don't know. If day is greater than 30, then we could then print out it's an invalid month if you want to do the invalid approach. But if you want to check if it's valid, we could do something like if day is greater than 1, or is greater than 1, and day is less than or equal to, less than or equal to 1, and day is greater than or equal to 1, and day is less than or equal to 30, print valid date, else print invalid day. So we can do that. And then we could see these, and again, we're going to test it not on just something. Again, when we want to test something, we want to try to both prove it and disprove it as best we can. And disproving it is often easier. In fact, when you conduct science, a lot of time, what you try to, this gets, for some reason, like this gets unemphasized a lot of the time, but one of the key areas when you're doing science is the idea of falsifiability, which is that your hypothesis, you aren't trying to prove that it's true. You're trying to prove your hypothesis false. You're trying to throw whatever you can to try to destroy your hypothesis. And only when it's withstood all your attempts to destroy it, maybe then you can present it to the scientific community. That's the idea here, because proving things true, that's an entire philosophical debate. But proving things false, that's something doable. So 04, 31, 2020, invalid day. That's correct. That's something we want. That's correct. And now 04, 30, 2020, that should say valid date. Now, what we can do in Python, in other programming languages, we have to do this. There's just no other way around it. But in Python, we can do it a lot more like we'd expect math comparison statements like this to operate, like we would in math. So if you're coming from from another programming language, this is wild. And if you're not, it's actually pretty, you'll see how useful this is. What I can do in Python is I can totally do this. I can say a valid statement like this. Pretty nifty, I personally think. Because other programming languages, they just don't like that. They'll yell at you and say, you can't do Boolean expressions like that. And Python's like, I don't care. So by the way, this makes this next part really easy too, over here. Because all we have to do is just copy what we have, paste it, and replace the 30 with the 31, right? So by solving one, we can copy and paste and solve the other one. Fairly easy. We don't have to bother making it a function there or anything, even though we're kind of repeating with a minor variation there, because only doing it twice. Well, third time here for February, but February now is going to be a little bit different, right? For February, we have this gets a bit more complex. For February, we want to check, okay, if it's going to be 28, if it's February 1st through 28, doesn't matter whether it's a leap year or not, right? And then if day is equal to 29, that's our leap year, right? We got to handle that, which we're going to do in a second. Okay. And then finally, over here, if it's not 1 through 28 and it's not 29, then we know for a fact that's not a valid day. There's no way if it's greater than 29 in February, it can't be good. So last thing left is to test this. Now, if we do all of our code in this if-else statement, it's going to get horrendously complex. Awful. So what I'm going to do is I'm going to scroll all the way up. I'm going to write a function called, and I'm going to just scroll all the way up and start at the beginning. Def is leap year. We don't need to give it anything else but a year. And what we'll do is that we'll use a return statement to return true or false. Return true if it's a leap year, return false if it's not a leap year. By default, we'll assume it is. Well, we can assume it. Well, that's actually tricky. What should we do? Well, first thing we should do is check if it's divisible by 4, right? And then if it's not divisible by 4, it's not a leap year. But if it is, could be. So what I'm saying to you is good luck. It's your turn now. So try to put your hand at that logic. And what you want to do, if it's true, if you find you're at a point where it is a leap year and you can definitively say it's a leap year, you write return true. If you're at a point in your logic where you can definitively say it's not a leap year, you write return false. Like so. If year mod 4 equals 0, that's asking if the year is divisible by 4, do something. That's what pass means. It means replace this. You shouldn't ever have pass in your code when you're done with something. Pass is kind of a placeholder for when you want to come back to that block later. It's kind of a fill me in later, but allows Python to go through the code without thinking there's an indentation error going on. Else, well, if it's not divisible by 4, we need to return false. So what I want you to do is fill in the giant block of code, not giant block of code, but a bunch of lines there that have where the pass would normally be. But this should help get you started. If the year is divisible by 4, it might be a leap year. And you don't have to keep this format. You can, there are some complicated math things you can do. But generally, if you're in this state, it's a possibly a leap year state. So go ahead and take some time for this. This one is rather difficult. And if you can get it, that's awesome, but I don't necessarily expect you to in like the 10 minutes I'm allotting here. It is a pain. Mhm.
Why you use double quotations. Okay. And quotations. Doesn't matter.
It doesn't matter, it depends on how I hit the keys. By default, I default to using double quotes because that's what the other programming languages use. And again, it's another kind of mental. So in other programming language, double quotes mean a string, single quotes mean a single character. That's what it does. So I try to use double quotes, but sometimes I miss the keys and, but it works, so I keep typing.
Yeah.
No, I mean, like, and it's.
So, yeah, but that's the kind of-
They're not like.
That people have to do.
I don't think I know. Yeah, but, no, it's.
No.
I mean, the expression comes first. I'm just saying, the good thing about it versus this.
And you're not-
That's what if you want that to. That's what I do. I never remember. And I just do that.
Because it's not-
Like, or, 57, that's what is it, what? This may do it at, as a. Here, that's, you know, that's essentially. So here is here. You can actually get it's all in like. Now, here, the one they were fairly exactly because the indication that here, there's all the references there, and then over here, it's not here, and then you want right to that. Okay. Not in, then you have the bracket, around 4, 6, 9. Tutoring, you know, if you're tutoring in, on the third floor of the building. Still different off. Tenth floor, 15 now. On campus. I did analysis. Did somebody else do that?
Well, you're one guy.
Time, I want to make sure I get this done for. Couple more minutes on this and then I'll put it up on the board. Yes. Since we are now at the answer on the
I'll go ahead and put the answer on the board. Now, what you want to do once you're done with the exercise, no matter where you are, just upload what you have. I will be checking this for participation, not for correctness. If you've uploaded, I will grade it out of 50. I'll put in a 50 out of 50. If you don't upload anything by the end of the semester, it will be a 0. So, you know. So upload something today so you don't have to remember to do it at the end of the semester. All right, yes.
You still want to create, participate one day.
Now you can remove that bit. Or you can keep it in if you prefer. It's fine. The logic here. So if it's divisible by 4, it may be a leap year. Now there's a lot of different ways we can do this. A lot of ways that we can do this in one line, but I want to kind of work through the logic one at a time. And I see I have some chat statements here. Yep. Sorry about that. Let me go ahead and I'll be sure to post this on Discord. I'm just dumping what I have in the chat. So if divisible by 4, then we have to ask ourselves, if this is divisible by 100, if the year is divisible by 4, if it's divisible by 100 as well, if year is divisible by 100, if year is divisible by 100, well, then that also might be a leap year, but it may not be. But if it's divisible by 4 and not divisible by 100, we know that it's a leap. We know that it's got to be a leap year, right? Now, if it's divisible by 100, it's only going to be a leap year if it's divisible. If year is divisible by 400 as well, right? If it's divisible by 400, we can say it's going to be a leap year. Return true. Else, return false. So it's a bit messy, but hey. Now there's other ways we can condense this, such as like checking, hey, if it's a leap year that's divisible by 4 and not divisible by 100, it's a leap year, or if it's divisible by 400, right? There's ways we can use, the fact that numbers that are divisible by 400 are also divisible by 4 and 100. We can use that to our advantage. But here, we're just trying to find, show that we can have a chain of logic here, an if-else statement. If-else statements, again, can be condensed down to flowcharts. There's a lot more elegant ways to do this. So if it's divisible by 4, oh, right, forgot one thing. Equal 0, moving too fast. Here is equal to 0. Yes.
Doesn't that put equals or just one equal symbol?
It does. A single equal sign is the assignment statement, and it's always the assignment statement. 2 equals is what you want to use to check are 2 things equal, like you would in a comparative statement, like with greater than equal sign or less than. Okay. So you will upload this on Canvas, under the page for this assignment. Just blame the Pope. It's under module 6 at this point. But now what we need to do is we need to fill out this last thing. We have this leap year logic. We now need to use it. So what we say, and so we can pretty much add this in here where we can say, if day is equal to 20, if it's the 29th day, we can now check if it's a leap year. Now we could add an and statement, but I want some extra leap year. But I want some extra information if it's leap year. So I say if year is equal to, sorry, not if year, if is leap year, print valid day. Now, the reason I didn't do a and statement there, which I could do, is that I just want to be able to do this right here in this piece of logic, which is else print invalid day, not a leap year. So I can pass on a bit of a different information. So here I can say 0 to 29 1996, that's a valid day. Run it again. 02, 29, 1900, invalid day. 1900 is not a leap year. And then we check the third case, which is a year divisible by 400. 02, 29, 2000. That's valid. That is leap year. All right, so let me go ahead and drop this in chat for the people on Zoom. I'm also going to go ahead and drop this on Discord. And if you need to, you can always come back to this conversation, to this video, which I'll upload. I'll have to check that question in Discord later. I do not have time to really meet after class today, other than for like a quick question, because I have to book a flight. So, and that service ends, that runs during business hours. And since this is international, it gets complicated.
Super quick. What is it, PIG?
Yeah.
Jim fixed that, and then I did extra credit for 4.5, and you
Mhm.
give him credit for that.
Right, I still have you queued in my Discord.
Gotcha.
I still have your message queued as a notification, as an unread notification, so I was gonna get to it at some point.
All right, got it.
But I do have it on my queue. Okay.
That sounds good.
See, question about their test.
How about this?
I just put this.
Yeah, don't worry about this again. Everything, yep, again, I'll be addressing those, you will get either full or partial credit depending on the question, okay? And depending on how we grade those.
So remember how I asked the question, like how I set it equal to like 1 comma that, comma that?
Yep.
Like, can you explain how it didn't work? You can't